Hello viewers, it's Abdurrahim Babatunde Kukola. This is another video on showcasing some of my projects on desalination plants. This is a model that I created for multistage flash desalination plants in Aspen Plus. The model is as follows. The seawater comes from the source, then mixed with the circulating water, the circulating brine, not water, because not all the brine is discharged. This process produces brine, and the brine that is circulating is returned with the process. This process produces brine, and the brine that is circulating is mixed with the seawater fed into the process and pumped to a very high pressure using this high pressure pump 4.6 bar. Then it goes into series of flashing stages that is model just like this. You can see these are the series of flashing stage. So it is basically this brine heater that's the main energy source. You have heating the process to a very high temperature, but before it heats to the process to a very high temperature, you first send it to heat exchanger that is attached to the flashing stage in order to use a source of heat to the stage. You understand? So you increase the efficiency of or separation of water from the brine. You understand? So and then send to the brine heater where it is heat up to the working temperature of the multi-stage flash. Then you get it to stage 1. The vapor will go up, go to this vapor collection condenser. Condenser is done on top. You understand? This heat exchanger is used to it is a cooling water. It's a cold water that is coming from the source. Then when the vapor comes up from this flash stage, it condenses with this heat exchanger. It exchange the heat with this heat exchanger, then condense to the liquid. So the liquid will not be allowed to mix back with the flash. So there is a liquid collector on this top that will only allow vapor to come in. Then the liquid will condense over here and will be taken out of the process. Then subsequently, that's what will happen in the next stage till when you finish the numbers of stages and you get your vapor distillate out and the blow down brine is returned here. You understand? So in this place, it's mostly removing heat from the brine. You understand? And in this place, the brine is rejecting heat. You understand? You are just cooling down the brine in this way. You understand? So then you have the circulation water. Although I don't think I modeled this circulation water. So but there will be another process. Maybe you are adding another brine to the process. You understand? So okay, make up, okay. And we turn the brine. So this is my heat recovery unit. As you can see, there is a lot of flashing. This is the flashing vessel. This is the separation water collector, condensation vessel for the water. And this is the next stage. There will be pressure drop definitely in the stages. You understand? So there will be model pressure drop as the water is coming from this place. There will be some orifice here to reduce the water a little bit, so that the system will have energy to flash off the water content. You understand? So apart from the energy supply from the vapor condensation, so then I think that's the main energy. I think that's the main energy. So this is the outlet from the condensation, the distillate that is leaving the stages. Why? Okay, this is the distillate. This is the vapor distillate. This vapor distillate that is leaving the stages. This one is mixed back and sent to the heat rejection zone. So this is the circulation. So brine. Oh, wait. This is the entering. Okay, this is the brine that is coming in, and this is the water brine that is going to the. This is the brine that is going to the brine heater. This is the brine inlet. All these are just for heat recovery. You understand? So this is not distillate, and that is the brine that is coming back from the brine heater. You can find the brine heater in this place. So this is the brine heater, is a furnace, can be anything, so it's just modeled as a furnace, and the temperature is set to 90 degrees Celsius, and this is the pressure that you want from the brine heater. This process has an advantage because it does the work at a normal temperature, and you don't need to get a very high temperature like supercritical water desalination. You understand? It use normal temperature pressure range. You don't need to get a very high pressure like the reverse osmosis desalination plant. So then you are able to get the products out, and then you model the pressure drop with a valve. You can even model it in the flash too. You understand? Irrespective. So you have multiple flash store that is configured together, and then you can see the distillate. This is the liquid distillate. Is mixed with the vapor distillate too. You understand? So this is just like the collector for the water that is returned. You understand? So this is the coming from the vapor. So the water that is condensed back is collected here instead of mixed with the what with the vapor with the flashing stream. No, it's not. So it's collected back because the water is actually very pure. It's actually very pure hot water, so it's part of the product. So that's the, you can see the water is very pure. So that is the for the heat recovery section. So you have the products from this flow sheet hierarchy. You go to the heat rejection section, just multiple stage but with no heat exchanger that is attached. So any heat that's coming in here is just released. You understand? So you only cool it down. You understand? So that's different between heat recovery and heat rejection section. So so then you have this flash, flash in subsequent stages. Then there is the major condenser for all the vapor. You understand? If there is any steam from the process or water is not being condensed in the stages, you understand? So all the steam is actually condensed in this way to room temperature. So you can get the room temperature for your water at 25 degrees Celsius, and the pressure is also given. Then the brine is sent there. Brine is sent out as for further treatment before returning back to the sea. Then you have the recovery brine is sent here. You understand? So currently I'm using this for my recovery. 90% is recovered. You can see while the remaining is 10% is sent out. So that is the multi-stage flash simulation with Aspen Plus. So and you can see the performance, the purity level of the water that is produced. If you check this place, you can see the purity level of water that is produced. It's very pure. So you, like I said, in the supercritical water desalination, you can use this to get an idea on how to create your multi-stage flash simulation with Aspen Plus. So thank you for watching. See you on the next one.